Okay, here we go. This is review 7a. This is going to deal with a lot of the e to the x and ln x type of first derivatives and integrals. So starting with 21, at x equals 0, which of the following is true about the function defined by x squared plus e to the negative 2x. We see this kind of increasing and decreasing types of answers. So what I'm going to do is take the first derivative, see what that gets me. So take the first derivative, f prime of x equals, sorry, let me make this a little bit wider here, 2x minus 2e to the negative 2x. That is the first derivative at x equals 0. So f prime of 0 equals 2 times 0 minus 2e to the negative 2 times 0. And oftentimes with this e to the x, you just have to remember e to the 0 is 1. That just happens all the time. Makes life a lot easier. It looks complicated in the beginning, but this gets real easy here. F prime of 0, therefore, equals 0 minus 2 times 1. So you get a negative number, negative 2 actually, so that is a decreasing function. Alright, let's get that out of there and keep moving on. The second part there, derivative of ln e to the 2x, just making sure you can manipulate logarithms there. Ln e to the 2x is what we're looking at here. That can be simplified. That 2 to the x can be moved out in front. Okay, and that is just going to be one of those logarithm rules. So it's just 2x ln e. Okay, so that is still the original function. I haven't done any first derivatives, haven't done any calculus yet. I've just rearranged it, which I can with the law of logarithms. Ln e, that should stick out at you. That is log base e of e. That's just 1. So this whole thing equals 2x. And so you're trying to find the first derivative of 2x. First derivative of 2x is just 2. Done. Okay, you just have to get handy with this. Ln e got to jump out at you. That is just equal to 1. Okay, so your final first derivative is 2. '23. The area of the region bounded by the curve, y equals e to the 2x, x-axis, y-axis, and the line x equals 2 is equal to. Just got to have a sense of what that curve looks like. Y equals e to the 2x, exponential growth of some sort, x-axis, y-axis, and x equals 2. All right, you're trying to figure out that area. That is just an integral. Okay, e to the 2x dx, and you're going to add all those up. You're going to add this up from 0 to 2 along the x-axis, and you can find your u is 2x and go from there. You should end up with C as a final answer. Make sure you can do that. That's not a tough problem. You want to make sure you can feel comfortable with that. 24. Sine of x equals e to the y. Kind of weird. We have x's and y's. We could do implicit differentiation. It can work, and that is fine and dandy. In fact, let's go ahead and do that for implicit differentiation. First derivative of sine x is cosine x. First derivative of e to the y is e to the y dy dx. Just as a double check, we have 1y in the original problem. We have 1 dy dx in our first line of first derivative, so we're feeling good about that. Finish up the problem here. We want dy dx equals cosine x over e to the y. That's kind of unusual here. Okay. Okay, we still have x's and y's together. We want it in terms of x. It said in the original problem, in terms of x. How do we get e to the y in terms of x? Well, we recall back in the very first thing here, sine of x equals e to the y. So this equals cosine x over e to the y, which is sine x, equals dy dx. So that is going to be cotangent x. Good to go. That is there. Okay. The other way of doing that, this was the original problem. I can rewrite that with logarithms. That is log base e, which is ln of sine x equals the exponent y. First derivative then, excuse me, is 1 over u du, 1 over sine x. Du is cosine x. Voila, you end up with the same thing, cotangent x. Either way works. Let's see, do we have any more? Okay, so move. Okay, we are at number 27. Moving forward here, so we've got dy dx equals tangent x and then y equals, and so you're just trying to integrate tangent x dx is our goal here. And we do have a little formula for that. I never remember the formula. I just write this down as sine x over cosine x. And I know my u is cosine x. My du is negative sine x dx. So I do have that in here. I just have to put a negative sign. Okay, or put a negative 1 inside and a negative 1 outside to balance that out. So I got a negative ln of cosine, absolute value of cosine plus c is my answer. I don't see that, okay? So I have to kind of figure out what I'm doing here. That negative can go as an exponent. So this is actually equal to ln of cosine negative 1 as an exponent. That's going to be equivalent to c, the secant. So the answer is just c there. Moving forward, 29, similar problem. You're just going to go ln of sine x pi over 4 to pi over 2. Plug those things in. Okay, so you get ln of 1 minus ln of root 2 over 2. You should end up with a. It takes a little bit of manipulating there. I'll let you kind of work that through, but you should end up with a for that example. Slope of the line tangent to the graph of ln x squared at x equals e squared is, okay, just, we can do this. Y equals ln of x squared. And we want to find the first derivative. And I think we can write that as 2 ln x is my original problem there. So my first derivative is 2 times the first derivative of ln x, which is 2 over x. All right, so there's my first derivative. And I want that at e squared. So I can get 2 over e squared. I think that's it. And the answer's there. Woohoo. B. 15, the area of the region bounded by the lines. Okay, we just need to graph that. X equals 0, x equals 2, and y equals e to the x, 1/2 x, I guess you would say. Still exponential growth of some sort. This is 0, this is 2. And so you're going to get e to the x over 2 dx. You're going to add those up from 0 to 2. So you need to integrate that. I'll let your u be 1/2 x. I'll let you go from there. You should end up with an answer. It's equivalent to C. We are on the third page there. We just got about 3 more problems here to do. We got, I guess, something that might look complicated. We're trying to integrate here. It shouldn't be too bad there. We want our u to be the exponent on e. That's what we're thinking, at least. So we can use our e to the u du formula here. So our u is x squared plus 2x. Our du is 2x plus 2 dx. We don't have that quite. We do have x plus 1, so that makes us happy. We can just plug a 2 in here and a 1/2 out in front to keep it balanced. Integrate from there on, and you should end up with B as an answer. '23 may look unusual to you or may not. I don't know. Some things you stare at it long enough might jump out at you here. Basically, we do have this h that's on the bottom here. Okay, this should look like, we've seen this before, this should look like the definition of the first derivative. The limit as h goes to 0, f of x plus h minus f of x over h. Kind of unusual. We're looking for, we're trying to zero in on that f of x back there behind the minus sign. Do we have that? I don't know that we really have that. Let me see what we have. So can we rewrite this where we kind of know where we're trying to head towards? Can we rewrite this? Well, we have the limit as h goes to 0. We have the h on the bottom, so that's good. The ln, when we have ln of a fraction, we can write that as subtraction ln of 2 plus h minus ln of 2. Okay, now that's looking like the definition of the first derivative. We're going to zero in on the item behind the subtraction sign, ln2. So what we're really looking at here is if you have a function equal to ln of x, we're going to try to find the first derivative of that at 2. Okay, we're not taking any limit. We're using the definition of the first derivative. We're just trying to find the first derivative, which is 1 over x. And we're going to do that at 2. Okay, because there was a 2 in here, and so we'll end up with 1/2 as a final answer. Okay, good problem. Once you kind of see it, you can definitely get the right answer. You know, definitely a star problem. Let's see if I can put a handy dandy star in here. Boom, star that baby. It'll happen on the AP Calc exam for sure. And I think we have one more to do here. Number 30. So trying to integrate this, nothing straightforward happens if you let your u be the denominator. It doesn't work very quickly. Since you have 2 terms on the top, okay, you can subtract it, or you can split them up rather. So you can make this the integral of x over x squared minus the integral of 4 over x squared. Okay, you can't do that if there was a difference of terms on the bottom. If there's 2 terms on top, you know, if you have you know 1 plus 3 over 5, you know, that's equivalent to 4 over 5. You can split that up and make it 1/5 plus 3/5. That works. The reverse is not true. If you had 5 over 1 plus 3, you cannot split that up. Okay, so this is what you have to do. Split that up. Take your time to integrate that. You'll work out, you have some ln's that come out of there, and you should end up with B as your final answer.